Is the screen visible?
Yes, sir.
Yes. Good morning. So in the previous class, we have discussed about the linking process, and we have seen how the linking was done. In fact, we have touched upon the reason behind the linking or the need for linking, because we know that there will be multiple programs which are independently existing, and if required, if they need to be communicating together for whatever the reasons, then we need to club them together or we need to connect them together. That connecting process is nothing but the linking. So what will happen in the linking process? Till the linking happen, or till the linking process, or before the linking process, what is the concept? Each program which were supposed to be loaded together will be existing on their own. Each one will be at their own location, no communication at all. So linking is going to bring them together such that after linking is over, all those programs, maybe 2 or 3 or 4, depending upon the number of programs, they will be put together in continuous memory locations. So once linking is successful, all these three so far independent programs, so far unique programs, so far separate programs will be put together or clubbed together. That is the concept of a linking process. And we have seen this as a mission dependent feature. Why it is a mission dependent feature? Because we have to make use of the so many modification records that are used inside the program. Thereby, modification records are part of our relocation. And relocation, we know it is a mission dependent feature. Thereby, this linking process is also one of the mission dependent loader feature. That's what we have seen now. So what to continue further, we have one concept of linking, which probably you should have an idea. Process is same what we have seen in the previous class. The way of representing the project your program, object program, can be further enhanced. How? Using a reference number. So let us consider, I'm just continuing the yesterday's class because one concept was supposed to be added. Yesterday I could not do that because it will be heavy for yesterday. Now since you understood how the linking is done, how linking process is accomplished, what is required for a linking, we have seen a diagram how the various unknown variables or so far not resolved variables or labels will be resolved after linking is over. All this we have seen. So for that we have used the various object programs like this, which are having your value called M, that is modification records and stuff this. So here if you observe, modification record up to this, okay, we know everything, and there is a plus or minus which is added to a extended. Now what we are talking about is this list B. You observe list B is repeated at somewhere else if possible. Yes, list B is repeated here, list B is repeated here. What else? List C is here, it is also repeated here as well. So end C, if you look at, it is repeated. So that means a same variable or same label is repeated at multiple places. So is there any better way to represent? Just improving the object program. That's what we're looking at now. Nothing to do with the linking, but can we improve the object program? So by providing a reference number is the one which is going to be given some number for this. For example, I am in program A. When I'm in program A, I will give 1 to PROGA. Then whatever you see, list A will be 2, NDA will be 3, like that. If I give some numbers, then probably instead of using list B, list C, and C, I can use some nomenclature which is called as a number. That number is going to be easily accessible than the names. That is the reason why we can use the concept of a reference number. So what we're looking at this point of time is, can we use a reference number in the place of a name? Why you are using now? It is not going to increase any efficiency of the program. It is only a better way of representing the object program so that it is easier for the loader to understand what are the labels to be added rather than going by the names. Because we may also do some mistakes while typing the names. To avoid that, better to go for a numbering system, which you call it as a reference number. So everywhere we can use the reference number. Now you can see the same program, what is here is replaced by numbers now. So numbers are written such that your first name of the program, that is PROGA in this case, is written as 1, remaining will be 2, 3, 4, like that. Depending upon the what values we have, what names we have, those names are going to be given some numbers. You can see number 2 is repeated at multiple places. Similarly, number 1 repeated. So number 4 repeated. So like this, a same name may be repeated at multiple places. That is how we are going to do that. So reference number is a concept. Reference number is a concept through which we are going to provide values, the numbers for the various values we have. And this is required for whom? When I'm in program A, I know the values of list A and list B. So I know the values of list A and end A. I don't want to use any numbers for them, isn't it? Because they are known to me. So I need numbers for whom? Values which I don't know. That is your R values. That is the references. List B, end B, list C, and end C. Only those labels where my data is, the details are not available with me, I need to provide the numbers. That's the reason why program A is what? This is a program A. This program A is given number 1. Next, list B is number 2, end B is number 3, list C is number 4, and end C is number 4. That's why you see now these values here, 2, 4, and all. So this is how we have to understand. This is going to be the values which require these names. And you can also observe that these names are given here. So 2 is given to list B, 3 is given to end B, 4 is given to list C, 5 is given to end C. This was not there earlier in this program. See, there are no 2, 3, 4, 5 here because we were not using reference number. Since we are using a reference number, we are going to update the R record also. R record is also modified with some number. Earlier we used to give address. Now we have given the number because 02 list B, 03 end B, 04 list C, 05 end C, like that. So we add these numbers at 2 places, one at the R record, other one at the all modification records. So this is just an information for you that in the place of the various labels and symbols that are going to be part of repeatedly or redundantly on modification records can be replaced with some numbers. And this is required for whom? This is required for those which are the external references, because external definitions are anyhow defined there only. We need not worry about them. Only external references need to be done. That's why it is called as a reference number. That is the number that is going to identify various external references is going to be our reference number. So if this is going to just help the object program to be represented in a better way so that loader can easily understand. So it's going to just improve the readability or improve the the efficiency of a loader in understanding the program. So execution remains same. It is not going to be get altered, but it is going to be a flexible way of representing your object code. So that's the concept of a reference number. Just keep that in mind. Nothing to worry. Now let us get into the third topic of our mission: dependent architecture features of a loader. So one, we have seen program relocation. Second, we have seen program linking. Third one is the algorithm or data structures and algorithm. As you have seen pass 1 and pass 2 of an assembler, now also we'll see pass 1 and pass 2 of a loader. Okay. So before we get into this algorithm, let us understand the functionality once again. If you recall, there are 4 functions for a loader to accomplish the process of a loading. What are they? One is the memory identification or memory allocation. Second one, program linking, that is various subprograms, if at all they are going to be there, we need to link, as you have just discussed in the previous class. After that, relocate the program. If the program is not able to be loaded at the available location or at the specified location, then we need to relocate the program which is available at that point of time. So suitably, how to relocate the program. We have seen how the modification records are used, how the various system is going to be in place to make sure that relocation is taken care. Now, at the end of all these 3 concepts are over, we have to load the program into the memory. So while doing so, we have just now seen in the case of a program linking, that we have taken program A, program B, program C. Program A had some references which were not resolved while you are in program A. They were resolved when you went to program B. Like that, at the end of going through all the programs, say program A, program B, program C, you are able to resolve the all labels. Like that, in pass one of a loader, what are we going to do? We are going to resolve all the necessary or the required addresses of those labels which are there as the external references. Since we are going to resolve them, we need to put them at one place, and hence we have a data structure by name external symbol table. We have used symbol table in the case of a normal assembler, where we have used all the labels that came in pass 1. We loaded them into the symbol table along with the address, corresponding address rather. Now we have that data with us, but that is not required here because it is already taken care. But what is required here is external symbol table, meaning that the labels which are not defined in my part of the program or my control section but defined elsewhere, they become external references. So I need to load them into a particular table called as a external symbol table. So all those references of external nature which are there in every subprogram or its control section need to be loaded into the external symbol table in the same fashion, that is along with the address and the name of the label. So if you recall, symbol table was used as a type of a hash table because symbol table has to load the data into the table and retrieve the data whenever we want. So symbol table was implemented as a hash table, while op tab was implemented as a lookup table. That you remember, isn't it? So similar fashion, your ESTAB, which is for external symbol table, is also representing various symbols but of a external nature here as far as the linking process is concerned or loading process is concerned. Thereby they also need to be taken care and they are stored in data structure by name ESTAB, which stands for external symbol table. So it is going to be in the same lines of a symbol table, which is a hash table and contains the name of the label and its corresponding address. So that is the concept of a data structure that we are going to use for the loader now. So that is one. So that is not sufficient because if you remember, if you recall the table we have seen yesterday, program A, program B, program C. So program A started at 4000, had a length of 63. We have added 4000 plus 63. It became 4063. That 4063 became the starting address for program B, and it was having some 51 bytes, and 4063 plus 51, we have made it a 47407E, like that. We have continued, meaning that once one program or a control section or a subprogram starts and ends, later the second program should continue. For that purpose, the connecting mechanism is required. So we require a concept of a variable which is similar to our location counter. So in this case, we are going to use two variables. One is control section address, other one is a program address. So control section address, as the name says, it is going to have the address of each of the control section, where program address is going to be one-time variable which will have the main address. For example, 4000 is my first address, address of a first control section. That is the number that is loaded into program address, that is PROG ADDR. It is not going to change. It will be permanently there for some time. Whereas CS ADDR will keep changing. So initially it is with 4000. After some time it becomes a 4063 because second control section is supposed to be loaded at the 4063, and if third is loaded 4100, your CS ADR will be changed to 4100. Like that means depending upon the number of control sections we have or subprograms we have, CS ADDR will keep changing in the course of the execution. Whereas program ADDR will be assigned once during one course of execution. It is there permanently until that particular case of execution is over, because it is a program. That means program address is similar to the control section address of the first control section. So first control section is going to be the beginning of the program, and hence the address of the first control section will be assigned as a program address. That's what we have to understand. So this is basically the data structures and variables required. So one data structure, that is external symbol table, which is designed in line with the symbol table, which contains name of the symbol. In this case, maybe external symbol along with the address, and it is implemented as a hash table. So the same thing will hold good here as well, but the name is different because we are dealing with only external symbols, not otherwise. So thereby we have one data structure and we have two variables, one for control section address other one for the program address. So control section address will be changing depending upon the new control section that is encountered, whereas the program address will be remain same in the given course of the program execution, because that program address is nothing but the address of the first control section or the first subprogram that we see in the program that is under the execution process or a consideration of the execution. This is how the initial information we have to keep in mind. Now, so program address is what we have, which is the control section address, and this program address is going to be the address what the program is going to take at the end of pass 2. So at the end of pass 2, what will happen? After entire loading is over into the program, your program has to be given for the execution. So that execution should be beginning from the starting address of the program, and hence operating system will be notified once loading is over that your program should start executing from this. If you recall, in the SICXC bootstrap loader also, we did the same thing. Once entire operating system is loaded into the memory, bootstrap loader as a last instruction will take the control back to the 80. Why 80? Because 80 was the starting address of the operating system. In the same fashion, once the entire program is loaded into the memory, program control has to go to the beginning of the program. So beginning of the program in our case is a PROG ADDR, and hence control of the operating system will be given to PROG ADDR so that the program can be executed without any issue. So this is how the pass 1, pass 2 is going to. So pass 1, we are going to make sure that every external symbol that is not known to me in advance, otherwise will be loaded or identified at the end of pass 1. So during pass 1, we'll keep on scanning and start adding that. And your PROG ADDR will be initialized with the CS ADDR, and thereby we'll go to the pass 2 with this information. In pass 2, what will happen? Any linking that is expected, that is M records and all, they will be accomplished, and later the program will be loaded into the assigned memory. Once loading is over, your pass 2 will be completed. Later, the control will be given to the operating system to go to the beginning of the program for further execution. So this is how precisely the functionality we have from the algorithm perspective. So algorithm I have just shared with you. Hope you might have received that. Have you received?
Yes, yes.
So you can keep that with you, and if it is not visible properly here, that becomes a place to verify for you. You can verify that, or if you're comfortable, you can go through this particular PPT as well. Okay. So your pass 1 is going to give you the intermediate values, but which are the values of every control section, its length, and control section address of a subsequent control sections. And it also gives me all the external symbols along with their addresses. Once that is over, your pass 2 will be coming into picture, whose responsibility is perform any linking that is supposed to be expected to be done, or any relocation that is supposed to be done at the end, loading into the memory. So all these 3 will be completed by end of the pass 2. So when you come to pass 2, you would have accomplished all 4. What are the functionality of loader now? Allocation of memory, linking, relocation, loading, all 4 would have been completed at the end of the pass 2. Then now program is ready for the execution. As the last instruction of a pass 2, will pass the control to the operating system to complete the execution. So that is what the process of loader as an algorithm. Any doubts so far?
No, sir.
Fine, thank you. So this is algorithm. So let us go in detail. So I will leave it to you. Go through that initially. It is in line with the assembler algorithm what we had seen earlier, but the only thing is functionality is different. In the case of an assembler, the function was to identify each instruction, verify if the instruction was valid. If it is valid, what is the size, and those stuff we have done. Later, we have verified each instruction. Later, we have converted into their internal form using mnemonics. We created the object program. We have written the T records because that was the requirement of an assembler. Now we are in the loader. What loader is supposed to do? Just keep those 4 functionalities in mind, and more so in the pass 1. What are we going to do in pass 1? We'll take the control section address, store it as a program address, take every instruction of an object program and assemble and check what is the what you call any external symbols are there, and take those symbols, store them into ESTAB, like that, keep on processing. So the result of a pass one is very simple. At the end of pass one, I should not have any unresolved symbol. If that is taken care, then finally we will be having the pass one. So pass two is very important, where we will be doing actual linking and actual relocation and final loading. So before we go to that, please go through this. If you have any place which is not understood, please let me know. Meanwhile, let me take the attendance. Asta?
Present, sir.
Abhinav? Aishwarya?
Present, sir. Abhinav.
Aishwarya?
Present, sir.
Ambrish?
Yes, sir.
Anu?
Present, sir.
Arbaz? Arjun?
Present, sir.
Ashok?
Present, sir.
Vinita? Bhargavi?
Present, sir.
Ravisha?
Present, sir.
Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha?
Present, sir.
Deepika?
Present, sir.
Deepika MB?
Present, sir.
Murali Krishna?
Present, sir.
Gangubai?
Present, sir.
Guriya Kumari?
Present, sir.
Harshit?
Present, sir.
Junjar? Kavya?
Present, sir.
Kishore?
Sir.
Lata?
Yes, sir.
Manisha?
Present, sir.
Manjunath?
Yes, sir.
Nayana?
Present, sir.
Nilanjan?
Yes, sir.
Nishant?
Present, sir.
Pavitra?
Present, sir.
Maithili? Priyanka?
Present, sir.
Pavan?
Present, sir.
Akash?
Present, sir.
Rajeshwari?
Present, sir.
Rakesh?
Present, sir.
Ramya?
Present, sir.
Rashmi?
Present, sir.
Ravishankar?
Yes, sir.
Rizwan?
Present, sir.
Vishal?
Present, sir.
Savita?
Yes, sir.
Shruti?
Present, sir.
Sneha?
Yes, sir.
Spurti?
Present, sir.
Srinidhi?
Present, sir.
Srinivas?
Present, sir.
Sunil?
Present, sir.
Vaishnavi?
Present, sir.
Vinny?
Present, sir.
Sir, Arvaka is present, sir.
Hey, what Arbaz? I want to call you. 5 classes continuously missed. Huh? What happened? Internet problem.
Yes, sir.
Then what is the solution?
Sir, Maithili.
Sir,
Who?
Sir, Maithili present, sir.
Sir, Abhinav present, sir.
Yeah, Abhinav, okay.
Okay.
Fine. You able to understand? Is it a self-explanatory?
yes, sir.
Can anyone explain me? Whatever you understood, nothing to worry. So you have input as object program. Object program contains HTE records, and that is input. And based on that, how loader is going to perform. And we have seen in pass one, the major rule is to make sure that the object program is identified one by one and see any unresolved references are there and make sure that they are added. So that's a major thing. So for that purpose, how algorithm should be. Just give a try. We will take lead. Is the first 3 lines understood? Any doubts in the first 3 lines? Begin, get, set. Tell something. If you have understood, you say understood. If you don't know, say don't know.
Sir, can you repeat again once?
No, I will repeat, but I want to understand whether you can self-read. It is not in Greek and Latin, no. And I have also told what is the process. And it is similar lines with the assembler. I am here to explain, don't worry, but can you understand on your own is my question. So when you read from the beginning, are you finding any missing data, something which you could not understand? If you can tell me, that will give me an idea where you are struck. Because some efforts need to be given from your end as well. And this can be easily understood if you read it from the beginning, keeping functionality of a loader in mind. If you can understand on your own, that is something good, because you will be able to perceive it better. When I explain, you may miss the flow. But if you read and you get understanding of this, that will stay with you for some time. You want some time to go through? Fine, take, no problem. But go through that from the beginning till the end. Which is not able to be understood by you, let me know. You can refer this, or you can refer the whatever the algorithm, same algorithm I have sent in mail in your Google Classroom as well. You can open that and see whichever it is. Both are same. But I want some of you to open and let me know what is that you understood. If you are wrong, don't worry. I am always there to explain. But I want you to self-try. Or one of you can start explaining from first line, so that if you go wrong, I will also add and I can help you to understand better. Will anyone volunteer? Start from this line.
Yes, sir.
Yes, please go ahead.
In password algorithm, we'll start with the beginning,
Hmm.
means starting of the program.
Yes.
Then we'll start reading the line by line.
Hmm. No, can you now go with this algorithm? What is the given? It is get program address from operating system. So what do you mean by this?
Getting the entire program address from the
See,
operating system.
yes.
We'll
So
get
we have four
we'll load
functionality.
we'll load the address to the operating system.
We load the address of the operating system.
No, sir. Program address to operating system.
Operating system is not going to. Operating system will only give you the address.
Yes, sir.
If you look at the four functionality, first functionality is what? Memory allocation. Who will allocate the memory? Operating system. Because operating system important for functionality is what? Memory management. So in the process of memory management, operating system will say, hey, look, you have a program of 1000 bytes. I have a free memory at 5599 location. You start loading your program there. So that 5599 or whatever the number, that number who has to give? OS has to give. So from OS, we are taking the address of the program. So that is what it is not OS taking. From OS we are taking. So we are getting the address of the program to be loaded. That is precisely nothing but memory allocation, which is given from the operating system. Is it clear? Yes. Next line. Yeah. Go ahead.
Set control address to the program.
So now we have seen program address. What is the program address? The starting point. That starting address has to be assigned to the first control section. So first control section, we are going to assign the address of the program. That is nothing but the PROG ADDR. So even if you remember the table in the previous class, it was a 4000. So 4000 was the address given to the program. 4000 was also the address of the first control section. So address of the first control section, which is a 4000, which is nothing but our program address. So that's what we have done. So initially we have assigned the control section address and we got the program address. That's it. Okay, next. So program memory allocation is over. What is the next one?
In while condition, we will start reading the end line by line.
Yeah. If it is E record, if you go until E record, you are going to read so many records. So between H and E record, what do you see? You will be seeing a T records. You will be seeing a D records, D. We will also see R records. We will also see M records. So all these four types of records are there. What are required for me in pass 1? I don't want M record because that is for modification. I'm not doing modification in pass 1. I don't want header record here because I'm not doing any name or understanding of the program. It is already done. I want only D record and E records. I don't want any T records also because I'm not dealing with anything. But probably I may require the length of the program, the length of the control section, which I can get from the header record. So header record is going to help me with the length of the control section. If you look at the header record, column 1H, 2 to 7, name of the program, 8 to 13, the starting address, 14 to 19, the length of the program. So that length is enough for me because 4000 plus 63, that 63, how do I know? I know it only from the header record. So what I need from pass or object program, I need the length of the program from header record. I need D records, I need R records. Any other record is not required for me. So that's what we are going to do now. So in D records, if they are available, we will store. Even R records of no use for me because R records, I can only get the name of the program, the name of the symbol. I will not have the address. So better we'll deal with the D records only, not even R records. So keeping that in mind, now go through. So first line. Yes, go ahead.
Read next input record. That is over, sir.
Which
Then
is nothing but your header record.
Header records.
Yes. So from header record, what do I get? Length of the program. So I'm going to load into one variable called as a CSLTH, some variable. You declare variable in the program. Like that, you declare a variable of your choice. So CSLTH is nothing but a control section length. Let us say 500 bytes, 60 bytes, 65 bytes, 70 bytes. That number I am going to add. So program address is there plus control section length. If I add that, I will get the address of the next control section. So that's what we see at the end. So when I am at the end, If you look at here at the bottom, I'm going to get the address of the next control section. How am I getting now? I'm adding the CSLTH to the CSADDR, which will give me the address of the next control section. That's how we are going to get now. Fine. I'm going to use it here. Till then, no use of this. Okay, next.
Search external symbol tables. If we any found external symbol table, we have to add that to.
Yeah, same process we have done in the symbol table also. We have checked if by mistake a name is existing, because labels or symbols should be unique in nature. There should not be any duplication. If a symbol is already existing in the symbol table, then we have to flag it as a error. If it is not there, then only we used to add. The same process here. Okay, if it is found, it is an error or duplicate. If it is not found, we will add that to the ESTAB. That's the concept. Okay, next.
While record not equal to end means up to the, if we not.
That means we are reading the object program now. Object program contains H, D, R, T, M, E. So until you reach the end of the program, I want to see only few. What are they? Header record. Header record I have already seen. What else is required for me? D records. So if D records are there, I will process them. Yes, go ahead.
Read next input record. If record type is equals to D, then
because all your external symbols which are known to you, they are not unknown to other labels, I mean other programs, and those labels are very important for the subsequent control section. So now what is available with you? D means they have been defined in the same control section and you know the address. So I will add such records or such labels into the external symbol table with the actual address. Yes, go ahead.
If you found any like any number of D records, we will add into the loop and we will store that in ST tab.
ESTAB.
ESTAB. If we found that, if it is already existing in that loop, we'll set as error flag. If it is not there, we'll store into the ESTAB.
Same process. Since it is an algorithm, we should also take care of the else part. In the sense, if it is already there, then I should flag it as an error. We have done recently also. If it is not there, then only I have to add. So while adding, what should I do? The control section address plus whatever the address indicated in the sub object program. If you remember also in one of the cases in the previous class, 0054 minus 0040, result is 14. Object code we have written as a 000014. So when I add 4000 to that, we will get it as a 4014, like that. So we have to add the CSADDR address with the address that is specified in the object program. Yes.
End for end while. If you find end record, we will end the process.
So what happened now? You from the beginning, we have gone through till the end of the program, identifying only D records. There were so many records, we have not touched upon them. Header record we have done. We don't want R record. We don't want T record. We don't want M record. We want only D record. So we have processed D records between the H and E. So once I reach the E, that means that is the end of the program. So once I reach end of one control section, that control section processing is over. Next, I have to get into the next control section. How do I do that? By getting the address of the next control section. So that for that purpose, we have added the CSLTH to CSADDR. So that will give me the address of the next control section. So what will happen for the next control section? Same process repeats. Same process repeats, but first line will not be there for it because first line is already given. The program address is already there. You need not do that. And second, from while onwards, the second and third and subsequent control sections will be considered. So that's how it is going to be taken. So this is a pass one. So what is the result of pass one? ESTAB is identified. So all your symbols which are defined in the current control section, they have been added. Like this, if I go to all the control sections by pass one, will I get the addresses of all the external references? At the end of pass one. So I will repeat this process for all control section. When I do that, my ESTAB, the external symbol table, will contain all the names of the references with addresses. So by pass 1, if I reach, I will be able to know all these symbols which were undefined at some places now being defined. Is it possible?
Yes, sir.
Yes. So we got the complete ESTAB at the end of the pass 1. So is it clear to all of you? Any doubts? You have not done anything great. Whatever the functionality we have just followed in 2 passes, pass 1 and pass 2. We are still at pass 1. Only first step is done. Remaining 3 we have to accomplish. We'll go to pass 2 for that. If you don't have any doubts, we'll move to pass 2. Okay. Go through it again. Take 2-3 minutes. Let me know if anybody will volunteer or you only continue otherwise. So what is need to be done in pass 2? We have to link, relocate, load. To that, what is required? Your T records are required and modification records are required. So T records to load the data into the memory and M records to link any missing contact. So once that is done, we'll go to the loading of the program, later execution of the program. Just go through this once again. Yes. If anyone will volunteer to explain. Who will volunteer? This looks bigger, nothing else, but the concept is very, very simple. That's what I said, don't try to by heart this, because algorithm is very simple if you know the functionality. If you just keep that in mind, you can write this. But if you try to by heart, there are so many places you will miss it. So there is no need for by hearting at all. Just understand the flow of the requirements of a loader program. Then you can do justice. Because it's not possible to by heart so many. We should not be doing as well. If that is the case, you will write pass 1 to pass 2, pass 2 to pass 1. Yes, able to follow? So end product of pass 2 should be linking should be over, relocation should be over, program loading should be over, and control should be given to OS to initiate the execution by passing the control to the beginning of the program. So this is the activity of pass 2. So keeping that in mind, just see how it is being done. So out of so many records, header record we have processed, D record we have processed. We are left with the R records, M records, and T records. So R records of no use for us because they are already informed in the ESTAB. They have been taken care. So nothing to worry. Now important is T and the M records. So T records are there for to load the program into the memory. That's why we read T records. Any relocation is there, we have to perform through the M records. So once that is done, program loading is completed. Then control will be given to the operating system with the starting address of the program to execute the program. Same thing we have discussed, we have put it in the form of an algorithm. So who will volunteer now? Sunil?
Yes, sir.
Nina
I
madam.
want it.
Yeah.
We'll start with the past too, sir.
ಅರ್ಥ ಆಯ್ತಾ ನಿನಗೆ?
Yes, sir, I understood.
Okay. Go ahead. I will not explain, you only try.
Okay, sir. We will set the control address to the means we will access the program address. We will add the control address to program.
Control section.
Control section, sir. And if we have any external executions like out of programs.
That is not the meaning there. We are setting, see, we are in pass 2. Pass 2 means what? We are at the beginning of the program now. So what is expectation of pass 2? To load the program into the memory, and once loading is over, to provide the address of the starting of the program to execute the program. So you do in normal programming also, what you do, you take a variable. If you feel that variable data is very important, you store it again in some other temporary variable. Do we do that or not?
Yes, sir.
Because we should not lose the data. So program address is what we have assigned in pass 1. It is the starting address of the program. So now we are assigning that to control section address, because control section address got changed so far in pass 1. Now it is having some different address. Now I want that to be reinitialized to the program address. So whatever we have done in pass 1, the same set CSADDR, we are repeating that because CSADDR is already modified for several cases in pass 1. I want to retrieve back to the old value, that is the beginning of the program address. So I need to reset CSADDR to program address. Now next is executable address. This executable address line you may omit, but we are doing that simply because during the course of the program, if at all program address is lost, I should not be having any issue, because whatever you have done is for the execution of the program. If address itself is missing, then better. It's like having a multiple keys for your house. So one key with you, one key with parents, one key at some bank Almira you keep. No, why? Because entire house should be protected. So the key, internal things you may not have multiple keys, but house as a whole, some entity, you might be having a multiple security. In the same case, the program address is only one value. I should not afford to lose that. So we are assigning that to another variable called as a executable address. So your value is at 2 places now. I can use either of them. So to just make sure that your program address is loaded properly or stored properly for future references, we are creating another variable by name executable address. And it also makes sense to rename it as a executable address, because at the end, if you observe here, we are going to change the program. Once loading is over, the program will be given control to go to the final, that is the executable address, to start the execution of the program. So that is the meaning. So go ahead.
We'll start reading from header records using while loop.
We require once again the length of the program, nothing else.
Yes, sir.
Yes.
I will check the control section. Yeah. CSLTH. That is a variable. User defined variable to set the length of the program. While
You
record
already done in pass 1. Same process.
Yes, sir. We'll start reading the records.
T record.
Yes, sir. If record type is equals to T, then move the object code from the record to the location. Means the adding the to the object code.
Yeah. Here we have to read that line. In absolute code load we have done now. If object code is in character form, convert into internal representation. Same line we have used in the absolute loader. When it came to SICXE, we have demonstrated taking the value, storing into accumulator, then into S, left shift, then taking the data, ADDR. That is what the internal representation. Same thing we have to perform. So a character form need to be converted into internal representation. Hope you all understand that particular concept of a converting. So that we have to do. Okay. Once that is done,
we'll start reading the modification records.
Yes. So P records have been continuously stored into the memory that is identified by the program ADDR, which in turn is part of our CSADDR. So CSADDR plus address, CSADDR plus address. That will give the actual address. So we are relocating the program now. We're doing that. What are we doing now? We are relocating the program. Okay, next.
We start reading the M records. Search ES tab for modification symbols name.
Because that is a place where we have the new labels. For example, when I am taking program A, I have used list B, list C. Where are they? They are in the reference table, that is ESTAB. So I take those values from them. Yes.
If we found them, add or subtract the symbols value at the location.
So if it is a plus, if it is a minus, we have seen modification records, no? If you look at this, we have M plus, M minus like this. So this, so M minus, M plus, plus 02, plus 04, plus 05, minus 04. So depending upon plus or minus, we keep doing that. So add or subtract. Fine. Next.
If it is not found, we'll set a
yeah, of course. Since it is algorithm, else case also should be taken care. If it is not found, yes.
We are reached at the end of M records.
Yeah. So like that we continue till we reach all the records. That is all T records, all M records are over. So T records will talk about the loading, M records will talk about the relocation and linking. So we have performed all the three aspects of our pass 2. Then what is left now? Sending the control to beginning of the program. So we jump to the location identified by executable address. Why? Because we need to execute the program.
So that's it.
That's it. So this is a program, algorithm rather, for pass 2 of a linking node. Anyhow, you have both the algorithms with you. Go through them once again. If you still have any doubts, we'll come back to it. Thank you, Sunil.
Thank you, sir.
So that's all for the day. So we'll get back to you in the next class. So we have completed the loader related mission dependent features. Now we'll come back to the mission independent features which are available, or we'll go to the design options. Let us see whatever is available. Okay. So thank you. That's all for the day.